Hi! This video is again about adding and subtracting rational algebraic expressions. But this time, this will focus on how you are going to add or subtract rational algebraic expressions having different denominators. So let us have first examples of fractions. So you are going to perform the operation on the following fractions. We have here 1 over 2 plus 4 over 3. So for you to add these two fractions, you have to make sure that your denominators are similar or the same. So you are going to think of a fraction equal to 1, wherein you can make your denominators the same. So we have 1 half times 3 over 3 plus 4 over 3 times 2 over 2. And then you will continue to solve. Then you will obtain on this first set, we have 3 over 6 plus on the second set, on the second fraction, we have 8 over 6. And then continue adding your fraction, the numerator with the other numerator, and then copy the denominator. So you will have here 11 over 6. Then if you haven't reduced this to lowest term, then this will be your final answer. Okay? Or there is another way of how you are going to solve 1 half plus 4 over 3. For example, you are having again 1 half plus 4 over 3. You are going to find for the LCD. So the LCD of this is 6. Okay? So we have here 6 divided by 2 is 3 times 1 is 3. Plus, we have here plus, 6 divided by 3 is 2, times 4 is 8. And then, continue in addition, we have 3 plus 8 is 11 over 6, which is also the same with our answer on the previous slide. Okay? Next, let us have 3 over 4 plus 2 over 3. So, just like what I have done on the first example, you have to make the denominators the same. So, you have to multiply this with a fraction equal to 1. And we have to multiply 3 over 4 by 3 over 3. And the second fraction 2 over 3 by 4 over 4. Then, you will have here in the first fraction, we have 9 over 12. And on the second fraction, we will have 8 over 12, and then add the numerator and then copy the denominator. So you will have here 17 over 12. Or again, if you are going to have another way or another method, we have here 3 over 4 plus 2 over 3. So again, find the LCD. So our LCD here is 12. So 12 divided by 4 is 3 times 3 is 9 plus 12 divided by 3 is 4 times 2 is 8. And then we have here to add. So 9 plus 8 is 17. So copy the denominator. So we have 17 over 12. Okay. Next, let us have 3 over 4 plus 1 over 8. Okay. So again, you have to make the denominators the same. So you will have, yes, okay, we have 3 over 4 times 2 over 2. And then since we have already denominator here a, so that's why you do not have to multiply this by any fraction. So we have here 1 over 8. On the first fraction, we have 3 over 4 times 2 over 2. It will become 6 over 8 plus 1 over 8. Then you will have 6 plus 1 is 7. Copy the denominator. So, your sum is 7 over 8. Okay? So, next, we have 1 over 4 minus 3 over 2. So, we have now subtraction. Okay? So, still what you have done in addition will also the steps that you are going to do in subtraction. So, we have 1/4 minus 3 halves times 2 over 2 because you have to make them similar denominators. So, we have 2 over 2 on the second fraction. And then, you will have to perform the operations here. So, we have 1 over 4 minus 6 over 4. So, we have 1 minus 6 is negative 5. Copy the denominator. So, your answer here is negative 5/4. Or, if you are going to solve that by finding the LCD, you will have here 1 over 4 minus 3 over 2. So, the LCD is 4 divided by 4 is 1 times 1 is 1. 4 divided by 2 is 2 times 3 is 6. So, we have here minus. So, we have here minus. So 1 minus 6 is negative 5. So over 4. So this is it. Okay? I hope you have no question. So let's have the last example. We have here 1 over 6 minus 2 over 9. So again, you have to make the denominators the same. So we have the lowest possible denominator, of course. So we have here, yes, multiply the first fraction by 3 over 3 and multiply the second fraction by 2 over 2. So we will have the denominator the same as 18. So the first one will be 3 over 18 from this one. And then from this one, we will obtain 4 over 18. So proceed in the operation. So we have negative 1 over 18. Okay? And if you are going to use finding the LCD, we can have here 1 over 6 minus 2 ninths. So the LCD here is 18 divided by 6 is 3 times 1 is 3. Then 18 divided by 9 is 2 times 2 is 4. So we have here minus. So we have here minus. So 3 minus 4 is negative 1. Then copy the denominator. So it's still the same. We have negative 1 over 18. Okay. So another topic you have to use, you have to recall for you to add or subtract RAE with different denominators is how you are going to find for the LCM. Because this will be helpful for you to find for the LCD if the given denominators are polynomials. Okay, so let us have 12y squared and 6x squared. Okay, so how are you going to find for the LCD of this set of polynomials? Okay, so you are going to factor out 12 first. So we have here 12y squared. The prime factors of 12 are 2 times 2 times 3. Then the factors of y squared are y times y. And then the factors of 6 and then x squared. So we have here 2 times 3 times x times x. And then you are going to use as one those who are having the same factor. So you will have here 2 times 2 times 3 times y times x times x. And the product of this will be your LCM. Okay? So you will have here 12. Okay? So let us use the variable that comes first in our alphabet. So we will have here 12x squared y squared. Okay? Or I also have here the answer. Okay? Next. How about if you have 16ab cubed, 5a squared b squared, and 20ac? Okay? So let us have 16ab cubed. So we have here 2 times 2 times 2 times 2 times a times 1, 2, 3. So this 3b's is equal to b cubed. Next, we have 5 a squared b squared. So we have 5 here. We have no 5 here, so you may also have here 5. And then we have here a times b times b. And then for 20ac, let us have the factors. We have 2 times 2 times 5. And then we have here times a times c. Okay. And then let us have the common. So list common multiple. So we have the common will be used as 1, 2 times 2 times a times b times b times b times 5 times a times c. Okay? So you are going to multiply all these factors. So your LCM here will be 80 a squared b cubed c. Okay. Let's proceed. We have the third one. X squared minus 2x and x squared minus 4. So we have to factor out first x squared minus 2x. So you may express this as x times x minus 2. And then we have to factor out x squared minus 4. You may express this as x plus 2 times x minus 2. So you will have x times x plus 2 times x minus 2. Okay? Because we have here 1, 2, then 3 because they are common. Okay? So we have here this one. Okay, next. For the last example, let us have, wow, it looks good. They are trinomial. So we have here x squared minus x minus 20 can be factored as x plus 4 times x minus 5. Then the other trinomial, x squared plus 6x plus 8 can be factored as x plus 4 times x plus 2. And then you have to multiply. So we have here x plus 4 times x minus 5 times x plus 2. So we have here the LCM will be x plus 4 times x minus 5 times x plus 2. So I hope you mastered how you are going to find for the LCM of the given set of polynomials, because this will be a great help for you to add and subtract rational algebraic expressions with different denominators. Okay, so let us have this question. Is the denominator the same? Okay, we have here 2 over 3x plus 5 over 2x. Okay, you're right. So they have different denominators. So that's why you are going to find for the LCD. Okay, so what do you think is the LCD of these two fractions? Correct. The LCD is 6x. Now, you are going to rewrite the expression using the LCD of 6x. Okay? So, you will have 2 over 3x times 2 over 2 plus 5 over 2x times 3 over 3. Just like what we have done on fractions. And then, you will obtain 4 over 6x plus 15 over 6x. And then you are going to continue in addition. So 4 plus 15 over 6x will be equivalent to 19 over 6. Okay? So there is no common factor on the numerator and the denominator. That's why this will serve as your final answer. Okay? Next, for example 2. You are going to add and you are going to write each answer in lowest term. So we have here 1 over 10 plus 1 over 15. Okay? So you are going to factor out 10 and 15 with the prime factors. So we have to use 10 with 2 times 5 and in 15, 3 times 5. So since 5 is common, so you may just use 2 times 3 times 5, so which is 30. So using the LCD 30, you will obtain 5 over 30. And then you are going to reduce this to lowest term. So this will be 1 over 6. Okay. For the second one, we have m over 3n plus 2 over 7m. So just like what we have done before. So your LCD here is 3 times 7 times n is equal to 21n. And then you will have m over 3n times 7 over 7 plus 2 over 7n times 3 over 3, which will result to 7m over 21n plus 6 over 21n. Then continue adding. So we have here 7m plus 6 over 21m. You will not have here 13m because our 6 here is just a constant. We have no variable m with 6, so that's why you cannot add the numerator. So you will just have simply 7m plus 6. Okay? Because 7m plus 6m is different with 7m plus 6. Okay? I hope you got it. For our next example, let us have negative 2 over p plus 1 plus 4p over p squared minus 1. Okay, so how are we going to solve this? So we have to factor out first the factorable. So in this case, p squared minus 1 is factorable. So that's why, so copy the first fraction. Then you have to write here addition sign. And then we have 4p over p squared minus 1 will be factored as p minus 1 times p plus 1 because it is under the difference of two squares. And then find the LCD by making your denominators the same. So you will have the LCD which is p minus 1 times p plus 1. And then you are going to distribute this using distributive property. Negative 2 times p is negative 2p. The negative 2 times negative 1 here is positive 2. Then we have here plus 4p. Then simplify your answer. So we have here negative 2p plus 4p is positive 2p. And then we haven't here any constant except positive 2. So that's why we have here positive 2. Then copy the LCD, p minus 1 over p plus 1. And then take note of 2p plus 2. This can be simplified. So this will result to 2 times p plus 1 over the LCD, p minus 1 times p plus 1. And as you have seen, p plus 1 is common. So you may cancel them out. And the final answer will be 2 over p minus 1. Okay? Let's have another example. Okay? So we have 2k over k squared minus 5k plus 4 plus 3 over k squared minus 1. Okay, so we have to factor first the factorable. So we have our first denominator can be factored as k minus 4 times k minus 1. And our second denominator can be factored as k minus 1 times k plus 1. And then you are going to look for the LCD. And again, if they have common factor, that will be used as 1. Okay? So your LCD here will be, okay, so just like what we have done on fractions, you have to make them similar denominators. So our LCD here will be k minus 4 times k minus 1 times k plus 1. You are going to divide these three LCDs with this 2 and then multiply your answer with k plus 1. And then, just like on the second fraction, the LCD will be copied. And then, divide this 3 with this 2, k minus 1 and k plus 1. So, you will left with k minus 4 multiplied by 3 later. Then, using distributive property here, you will obtain 2k squared plus 2k times 1 is 2k plus 3 times k is 3k and 3 times negative 4 is negative 12. Then, you are going to simplify because we have like terms here. So, you will obtain 2k squared plus 5k minus 12. Then, copy again the LCD. Then, if you can factor this out, you are going to factor. Okay, so this is factorable. So, you may factor this out as 2k minus 3 times k plus 4 over the LCD. Then look for the common factors on the numerator and the denominator. Since we have no common factors, so this will serve as your final answer. Okay, yeah. Sometimes you have wrong answer. Okay, although it is already in simplest form. Okay, so let us have example 5. Okay, so we have denominators that are opposite. So, as you have seen, we have positive 2m here and negative 2m on the second denominator. And on the first denominator, we have negative 3n, but on the second denominator, we have positive 3m. So, in this case, you are going to multiply by negative 1. Okay, so that you may obtain here negative 3n just like on the first denominator. Then, okay, so just like this one. If you are going to multiply the second fraction, but you are going to take note that you will just multiply negative 1 with one of the fraction, not both fractions. So, we have here to copy the first fraction, m over 2m minus 3n plus, you are going to multiply the second fraction by negative 1. So, you will obtain here negative n times, n times negative 1, we have here negative m, over 3n times negative 1 is negative 3m. Then, negative 2m times negative 1 is positive 2m. So, therefore, this time, our denominators are already the same. Okay? Because We already have here positive 2m, and we already have here negative 3n, just like with the first denominator, as the same with the first denominator. Okay? And then, continue in the operation. So, you cannot add m and negative n. So, simply, you will obtain m minus n. Because, again, you can only add or subtract polynomials if and only if they are like terms. Okay? So, we have here 2m minus 3n on our denominator. So, we have here the final answer. Again, m minus n over 2m minus 3n. Okay? So, I hope these 5 examples will help you on how you are going to add or subtract rational algebraic expressions with different denominators. Goodbye for now.